Hi guys, this is our second video, 2-2. So we are in chapter 2, section 2 of our new textbook. I'll be getting you guys the textbook here hopefully sooner than later, but no promises. Again, if you want your own textbook, you can let me know and I will get you a copy of the older version. That way you have one at home to look at. This section is called conditional statements. And conditional statements are statements that have an if and a then. So I've started out with the definitions. Conditional is one of the words that you need to know. It is an if-then statement. So if I have 2 feet, then I am human, for example. That may not be true, but it is a conditional. The hypothesis is part of the conditional. The hypothesis is the beginning part that is following the word if and ends at the word that starts before the word then. So if I have 2 feet, then I am human. Well, the part that is I have 2 feet, that's the hypothesis, where the conclusion is what's following the word then. So the conclusion in that statement would be, I am human. We also have what we call converse, inverse, and contrapositive, and I'll talk about those in just a second. But I want you to start getting familiar with symbols. So you'll see here that I put P and Q. That's important to know because a conditional statement can be written with symbols. You may have heard me talk about mathematicians or math people like to use symbols or short terms or whatever because we're just lazy, and you'll hear a lot of mathematicians make jokes like that. So P is what's the following the if, that's a hypothesis. If P, then Q. When you see that statement I just wrote, that's what you need to think. If P, then Q. Or P implies Q. Now, the P, again, hypothesis. Q is the conclusion. So if P, then Q, or P implies Q. You can also draw that as a diagram, more so a Venn diagram. And the way that would work is you could possibly have a Venn diagram where P is inside of Q. So if P, then Q. The Venn diagram that I showed, or that I just drew, illustrates how the set of things that satisfy the hypothesis lies inside the set of things that satisfy the conclusion. So the hypothesis is inside of the conclusion. So to write a conditional statement, you're going to use the given hypothesis and the given conclusion that they provide you in the question, and you're going to write it as if P, then Q. So for example, if it said, if the measure of angle A is equal to 15, then the measure of angle is acute. Well, the measure of A equals 15 was my hypothesis. Angle A is acute is my conclusion. They would tell me angle A equals 15 and angle A is acute. Or they would say the measure of angle A equals 15, so the measure of angle A is acute. And you could turn that around, and as a conditional statement it would read, if the measure of angle A is 15, then angle A is acute. The converse is the next word listed, and converse is the term that is used to take the conditional and flip it. So earlier I said, if the measure of angle A equals 15, then angle A is acute. Well, now, if I'm writing the converse, I'm going to say, if angle A is acute, then the measure of angle A equals 15. So the converse is Q implies P, or if Q, then P. The inverse is the same as the conditional, except what we're going to do now is what's called negate we're going to negate the hypothesis and the conclusion. Now, what that means is write the statement but make it false. So, for example, instead of saying the measure of angle A equals 15, we're going to negate that and say the measure of angle A does not equal 15. Now, remember, when we say does not equal, that's just an equal sign with a slash through it. So, when we draw that, or when we write that with P's and Q's, we write this symbol, and that's probably familiar to you because it's at the top left of your keyboard on a computer or on some kind of keyboard that you may have. It's next to the 1. It's a little symbol, and in geometry that symbol either means similar, which we've talked about that. We'll talk about that more later on in the class in the future, but it also means a negation or a negate. So not P implies not Q. So the inverse of my original conditional statement was, if the measure of A does not equal 15, then angle A is not acute. And then we have what we call a contrapositive. And a contrapositive is the mixture of the converse and the inverse. So we're going to take the original conditional and flip it and negate it. So not Q implies not P. If the angle A is not acute, then the measure of angle A is not equal to 15. Okay, so some important information for you to know, and this is something that you're going to have to find a way to remember. There really isn't an easy way that I know of to memorize this, so this is just something that you need to have a good, solid understanding and a good memory. So I'm going to go ahead and just read it off. A conditional statement and its contrapositive are always equal or always equivalent statements. So they're either both true or they're both false. So if this is true, so is this. Now, if you actually read our statements here, they're the same statements that I just said a second ago, and so I wrote them down so you can see. The conditional says, if the measure of angle A is 15, then the angle A is acute. That's a true statement, because all angles that are greater than 0 but less than 90 are acute. If our conditional is true, our contrapositive is true. Now let's take a look at our converse and our inverse. Our converse says that if angle A is acute, then the measure of angle A is 15. Well, that may be true, but not all of the time. So we would actually call that a false statement. If the converse is false, then so is the inverse. So if I'll finish reading up on the top, the converse and inverse of a statement are also equivalent statements. So if one is false, the other one's false. Again, that's something that you're going to have to remember. That is, the conditional and the contrapositive are equivalent, and the converse and the inverse are equivalent. So find a way to remember that conditional and contrapositive go together and that converse and inverse go together. But remember that the converse, inverse, and contrapositive are all created from the conditional. However, if you know the contrapositive, then you know the other three statements. And what I mean by that is if I told you that the statement was if angle A is not acute, then the measure of angle A is not 15, and I said, okay, well, that's the contrapositive, find the conditional, converse, and inverse, you can find those three based on the information from the contrapositive. So know that also that's something you need to be familiar with. They're all similar with each other. The conditional and contrapositive have the same truth value, so true or false. The converse and inverse have the same truth value. But you can also write the other three when you're given one of them. Okay, so here's an example of how to take a statement that you are given and turn it into a conditional statement. Remember that if you know the conditional, you can write everything else. So sometimes it'll say, what is the conditional, inverse, converse, and contrapositive? Well, you want to start out with the conditional because that's basically your step one, and then you can turn that into everything else. The statement we have here says vertical angles share a vertex. The first thing you want to do is determine what is the hypothesis and what is the conclusion. Well, if you read here, the hypothesis is vertical angles. The conclusion is share a vertex. So when we write that as a conditional, we need to make sure that we put our if and our then. So I'm going to write that out in black. I'm going to write the word if and then. And this is going to flow as one sentence, but I'm writing it as the if and then just to show you as an example. So when you write it, you can write it on one single line. I'm just writing it like this, again, just for our example. So now here's where you have to make sure your English is proper. You have to make sure that you write it in a sentence that makes sense. So if I said if vertical angles, then share a vertex, that makes no sense. You may think that it makes sense when you're writing it, but when you read it back or when somebody else reads it, they're going to be really confused because they don't know what you're talking about. So you have to find a way to take it and turn it into a statement that makes sense. We know that when we have vertical angles, we have two angles. So that would be a good way to write this. If two angles are vertical, then, and here's again, if two angles are vertical, then share a vertex doesn't make sense. So we want to add in a word, they. If two angles are vertical, then they share a vertex. Oops, let me fix that because that looks like an 8 and not an S. Then they share a vertex. So if I were to read that out loud, if two angles are vertical, then they share a vertex. That makes sense. If then. We can now take this and turn this into a contrapositive, turn it into a conditional, turn it into an inverse, and we can also find the truth value. Here are a couple extra examples. These are going to help you determine how to properly find a counterexample of a conditional statement. So you have the first one, if a woman is Hungarian, then she is European. And then the explanation with the answers below that. Then the second one, if a number is divisible by 3, then it is odd. And then there's an answer with an explanation below that. And then to the right of the answer on that one, it kind of gives you a little bit of an extra assistance, I guess you could say. How do you find a counterexample? So there's just a little bit extra there. And then on the bottom, if a month has 28 days, then it is February. And then there's the answer with the explanation. So hopefully when you come to class on Monday, you'll have a really good understanding of what a conditional statement, inverse, converse, and contrapositive is. And be prepared to come with some questions too. Make sure you took some good notes, pause, rewind, all that good stuff. And I hope you'll have had or have, depending on when you're watching this, a great weekend. And I'll see you Monday morning or afternoon.